Hi everyone, my name is Alda Cahyaningtyas. You can call me Alda. This is my interactive presentation number 7. It's a submission for General Chemistry 1 that I'm taking with Doane University. And today I'm going to be talking about selenium sulfide or selenium disulfide that's found in my Selsun Blue shampoo for dandruff. Hope you enjoy this video. First of all, I'm going to be showing you the Lewis structure of selenium disulfide. First, we're going to need some sticks. You can use like a popsicle sticks or any sticks that you have at home. I happen to have the treat sticks, so they look like this. And then I also have with me 2 colors of Play-Doh or modeling clay. You can call it that way as well. You can use any color you want, but I would suggest that you have different color for different atoms, so that way you will be able to differentiate which one is which atom. I have with me a purple one and a green one. We're going to make a Lewis structure of the selenium disulfide. I'm going to use purple for the selenium and then green for the sulfur atom. So I'm just gonna open this first. Should be easy. I have taken some modeling clay or Play-Doh out of the container, and the sticks are going to represent the bond that's formed between each atom. Meanwhile, as I previously have talked about, the Play-Doh is gonna represent the atom in the molecule. So first, I'm just gonna make this more solid, more round, more of a proper shape. I haven't played with Play-Doh in a while, so might be a little bit rusty. It's not perfect, but I think this is doable. And now I'm just gonna divide this into 2 because we have 2 sulfur atoms. And now we have 2 sulfur atoms and 1 selenium atom. And now we're just gonna connect them with the sticks. Selenium and 2 sulfur atoms, they make double bond. So I'm just gonna put 2 sticks to represent the double bond. Let me make sure that this is strong enough. Like this. And then like this. So this is the Lewis structure of selenium disulfide. It has a bent shape. A bent shape is formed when there are 3 electron groups and 2 ligands. With this kind of model, you're unable to see the lone pair that's contributing to the 3 electron groups because this is 1 electron group, this is another 1 electron group, and there's supposedly a lone pair with the selenium atom. So I was able to draw a Lewis structure, and this is what it looks like. So this is the sulfur atom, another sulfur atom. Each of them create double bond with the selenium atom in the middle. And this one is the lone pair that's contribute to the 3 electron groups. And because they have 3 electron groups and 2 ligands, they make the shape bent, which has a degree of 109.5 over here. So this degree is supposed to be 109.5. This is not an exact model, obviously, but this is supposed to be showing you not a 90 degree, because a 90 degree would have been like this, but it's bigger than a 90 degree. It's 109.5. And now let's talk about the molecular geometry of selenium disulfide. In molecular geometry, you would want to ignore the lone pair that's involved in the formation of selenium disulfide. So here is the model for selenium disulfide in the molecular geometry. Because we're ignoring the lone pair that's involved in selenium disulfide, now instead of having 3 electron groups, we have 2 electron groups. And with molecular geometry, when you have 2 electron groups with 2 ligands, now you have a shape of linear. In linear shape, you'll observe a 180-degree shape. So this is a 180-degree shape. I'm sorry, it's kind of a little bit bent. So to recap a little bit, for the molecular geometry of selenium disulfide, it has a shape of linear, which is 180-degree. Meanwhile, the electron geometry, which is going to be a bit like this, the electron geometry is bent because now it has 3 electron groups and 2 ligands. With the bent shape, it has 109.5 degree. Now let's talk if there is any individual polar bond in the molecule. So selenium, let's see. Selenium has a electronegativity of 2.55. Meanwhile, sulfur has an electronegativity of 2.58. The difference between these electronegativities of selenium and sulfide is only 0.03, which means it's lower than 0.5. This means that it is a non-polar covalent bond. Selenium disulfide is also a non-polar molecule. Let's have a quick recap. It doesn't have any individual polar bond, and also it's not a polar molecule, meaning it's a non-polar molecule. And lastly, this is a covalent bond. The reason why we can determine that this is a covalent bond, it's because none of the atom donate or receive any electron. So they equally share the electron and form covalent bond. Thank you for watching this video. I hope you find it informative. I hope you were able to learn more about selenium disulfide, which is easily found in many anti-dandruff shampoo, which I'm currently using right now. Hopefully that I was also able to explain the shape, the structure, and also how they're bonded and the polar activity or the electronegativity of the molecule as well. Thank you once again. Bye bye.